It's Geometry Week 3 and we're going to learn about triangles. This is what we're going to learn about today. So first off, we're going to learn about types of triangles, and we can separate them by angles and by size. So first of all, for angles, there are 3 types of different angles in a triangle. The first one is acute triangle, which has all 3 triangles are less than 90 degrees, which is a right angle. So none of them really have a right angle. And this one is a right triangle, whereas this angle is on the bottom right. That is a right triangle which has a 90 degrees, and the other 2 adds up to 90 degrees, and all of them together are 180 degrees inside. And the last one is obtuse triangle, which the bottom right angle is more than 90 degrees. And by side, there are 3 triangles as well. The first one is equilateral triangle, whereas all the sides are equal to each other. And the second one is isosceles triangle, whereas 2 sides are equal to each other. And the third side is smaller than the sum of the 2 equal sides. And the third one is scalene triangle, which has no equal sides, so all of them are different length. So the next thing we're going to learn about is perimeter and area of a triangle. So perimeter of a triangle is the lines that goes around the triangle, which is A, B, and C. So if you want to find the perimeter, you add all the length together to get the perimeter, which is A plus B plus C. So for example, in this problem, if we want to find the perimeter of the triangle, we add up 11, 13, and 8 to find the perimeter of this triangle, which equals up to 33 centimeters. And next thing, we're going to talk about area of a triangle. So basically, area of a triangle is height. Area equals 1/2 base times height, whereas base is the blue line you see the bottom of a triangle, and height is the altitude, which is the line from the top of the angle to the base, and the base and the height have to form a 90 degrees angle. So basically, here, this is a 90 degrees angle. And this formula, it came from a square or rectangle. Both are the same, but it came like this because you can see that half of a rectangle or square is always a triangle, and then since triangle and this entire square, they have the same base and the height. The base of this triangle is this portion, which we can call A. Actually, let's use we can use H, and this part we can call it B, which is base. And here they form a 90-degree angle because we know square and rectangle all have 90 degrees angle on their corner. And you see that this entire square or rectangle, the area would be H times B equals the area of the square or rectangle. And for this triangle, the area would be 1/2 times H times B equals the area of the triangle, because it's the area of the triangle is 1/2 of this square, so you times 1/2 to the H times multiplied by B, so you get area of the triangle. Okay, so in here we have some examples where you can find the height of triangle. And basically for a right triangle, the base or the height, they're the same, but you can just say one is height and the other one is triangle. No, the other one is the base. So in here, 5 can be the height and 8 can be the base for the green triangle. And for the what is it called? For the blue triangle, the 7 would be the height because it's a straight line down, not like the 9 centimeter, which is slanted. So the 10 would be the base. It's pretty obvious that 10 is the base in this case for blue triangle. And like we said, height have to be perpendicular to the base. So in this case, 90, the 9 centimeter line wouldn't form a perpendicular angle to the 10, whereas the 7 will form a 90-degree angle to the 10 centimeter line. And in this case, for the yellow triangle, it's also the same as blue triangle. The 14 the 14 wouldn't be the base. The 10 would be the base because 14 is the total length of, it's not like a really direct length of the right side of the yellow triangle, but 10 would be the direct length of the yellow triangle on the left side, and 5 would be the height because 5 is perpendicular to the 10 centimeter line. So for this triangle, you can find the area. So first of all, you have to find the base and the height. And in this case, 7 would be the base, which is obvious. And we have to use 6, which is perpendicular to the base 7 centimeter line instead of 8, because 8 is not perpendicular. So we use the formula A equals 1/2 base times height. So we would do A equals 1/2 times 7 times 6, which equals 21 centimeters squared, because since we have 2 centimeters multiplied together, it will be squared instead of just centimeter. And now we can go into similar triangle.
So similar triangles are two triangles that have the same angle degrees, but they have different sides. So like as you can see in these two triangles, like they have the similar angle degrees, like this angle it's 59, and over here it's the same thing. This is also 59. And while here this is 63, this is also 60 over here. And the last angle is 58, and over here it's 58 too. But now that you see that since this angle is obviously bigger than this triangle, the sides are different. Next slide, please. So how do we find a similar triangle? Well, we have to use the similar triangle theorems. So the first way is when the triangles have two equal angles. That's called an angle. And the second way is if the two triangles have two similar sides and one angle in between. And the last one is when all three sides of the triangles are equal. That means the degrees are also equal too, which means it's also a similar triangle. So scale factor is the ratio that you get when you divide corresponding side lengths with similar figures. So as you can see in here, there's two triangles. One is bigger than the other. Can you play the next animation? Yeah, so like from the big triangle, if you go from the big triangle to a small one, you have to divide all the sides by 3. Like 9 divided by 3 equals 3. 12 divided by 3 equals 4. And 15 divided by 3 equals 5. But if you want to go to from the small to big, you have to times it by a scale factor of 3. So like 3 times 3 equals 9, 4 times 3 equals 12, and 5 times 3 equals 15. Similar triangles have proportional sides. So what that means is that you could find the unknown sides here by using proportion. So what you do is you put the big triangle, big over big equals small over small. So 24 over 21 equals 16 over x. So that would be 24x equals 16 times 21, which is 336, and you divide both sides by 24, and you'll get x equals 14. So this side will be 14. And you can also find the scale factor since these two triangles, they are similar because they have two equal angle degrees. So to find the scale factor, you just divide it by the corresponding sides. Since 24 and 16 are corresponding, you just do 24 over 16 and you could get a scale factor from the big triangle to a small one. And the scale factor is 1.5. Okay, next slide. Now we're gonna play some Jeopardy.
How much do you want to start from?
Let's start from like 100, vocabulary 100. So, similar figures have the same blank, but not the same blank. So as you can remember from the slides that we went over, similar triangles have the same angles, but not the same size.
What do you want to do next?
Let's go down the vocabulary. In similar triangles, corresponding sides are blank, corresponding blank are congruent. So in similar triangles, corresponding angles are congruent. In similar triangles, our corresponding blank are in proportion. So in similar triangles, the sides are in proportion. So scale factor, it's when you want to go to a big shape to a small shape, you have to times it by scale factor. Or
the vice versa, yeah.
Yeah, or the vice versa. And this line goes through a vertex through the hypotenuse. So this is if you remember the right triangle, the side, let me draw it. So they're talking about this length here. So that is the height or the altitude of a triangle. So now we have to find the angles of B and D. Now we know that these two triangles, they are similar because they have two similar angle degrees, as you can see here, and that's a angle to angle similarity. So now we have to find angle B and D. So we know that triangles, they add up to 180 degrees. They add up to 180. So you just do 59 plus 60, which equals to 119, and then do 180 minus 119.
61.
Which is 61.
So angle D equals 61 and angle B equals 60.
Yeah. State the corresponding angles. Okay, so as you can see here, these two triangles are similar because their sides are in proportion. Because all the sides, they have a scale factor of, is that 28? Yeah.
Yeah, it's a scale factor of 3 to 2, I think.
Yeah. It's a scale factor of 1.5.
Yeah.
So now you have to find the missing angles. So again, 60 plus 51. 68 plus 51 equals
119.
119, and then 180. 61. And the other missing angle, yeah.
So I think basically angle E and K are the corresponding ones, F and L are the corresponding ones, G and M are the corresponding ones. So angle E and K has 51 degrees, F and L has 68, and M and G has 61.
So like this.
Yep.
So some of the answers on here, because I found this online, so someone else made this, I didn't make this.
Is this more of like a proof?
Oh, given the triangles are similar, how do you prove where the chord? Yeah, that's kind of more like a proof.
Okay, then we're just gonna skip this. Oh, this one is not hard.
Yeah. Label the corresponding angles and sides. Okay. So as you can see, there's like a 90 degrees angle here, and there's a 90-degree angle here. So P T. Right? So can you see what I'm writing?
Yeah, I can see you're right. Maybe you want to change the color
Okay.
because it's blue. Or I can write it if you want.
Okay, you can write it. So PT is corresponding to SR.
No, let me write. Why doesn't it let me write? Oh. PT is corresponding to SR.
And over at angle Q, at point Q, there's like a vertical angle, which means they are congruent.
These two angles are congruent, which is angle PQT is congruent to angle SQR.
And then the line TQ is corresponding to line QS.
TQS.
And the line PQ is corresponding to the line QR.
PQ and QR. QR.
And the angle TPQ is corresponding to angle QRS.
QRS. We basically proved that they are similar triangles because for the AA theorem, which is angle theorem, you already see that there is two congruent angles here because they're opposite of each other, and then we have two 90 degrees angles, so basically they are similar triangles, so we can prove that these are all corresponding to each other.
Label the angles and find all the missing angles. So we are doing like what we did before. So these two angles, they are similar because their sides are in proportion. And now we just have to find the missing angles. So it's 49 plus 62 equals
111.
111. And then 180 minus 111.
69.
69. So this angle over here is 49 also. This is 62. And the missing angle over here is 69.
Mm-hmm.
Do you want to do this one, Emily?
Yeah. So basically, we're trying to find x, which is length of this line, and as you can see, these two angles are proportional, which is similar. So their perimeters are also proportional. So we can find it by find the factor, then we can multiply to 30 to find the x. So basically 54 divided by 9 equals 6. And we also know that 54 divided by 9 equals 30 divided by x. So 54x equals 30 times 9. So 54x equals 270. So we divide it by 54 on both sides. We get that x equals 5. So this x equals 5. Okay. And here we have another similar question. And I'm pretty sure in this case, this x is corresponding to this 10. This 99 is corresponding to this 9. So we can set the portion again. I think the best way to find these answers are to set these proportions because they're really easy to solve. Oh, wait. So you set them equal. Why am I keep doing this wrong? So 9x equal to 990 divided by 9, x equals 110. So this x here equals 110. Okay, here we have another one, and in this case, we can see that this 11 and 12 are corresponding, so this x and this 16 are corresponding, so 11 over 22 equals x over 16. So 11 times 16 equals
176.
Yeah, equals 22x, which is also equal to 176. Divided by 22, you get the x equals to 8. This line here equals 8. Okay. So here we have to find 2, which is x and y, and in this case, it's nothing hard. It's just same, but then you have to find another side as well. So in this case, you can see that 54 and 42, they are similar. No, they're the corresponding sides. So 54 divided by 42, you get 9/7. So you would multiply 9/7 to 28 and to 35 to find x and y. So basically 28 multiply 9/7 equals 36. 36. And 35 multiply 9/7 equals 45. So this is x, and this would equal to y. Yes, that's what we got. Why do we know that these triangle sides can be found? We know that these sides can be found because, as you can tell, this is an equilateral triangle. So that means that all the sides are same congruent. So this side is also going to be 5. This side is also going to be 5. This side is going to be 15. This side is also going to be 15. Okay.
So a tree casts a shadow of 7.5 feet long at the same time that a woman 5 feet tall casts a shadow 3 feet long. How tall is the tree? So now we have to draw our own triangles. They don't give us a triangle anymore. We have to draw our own. So this is the tree, and this is the shadow that I cast. So the shadow that I cast is 7.5 feet. And a woman who's over here, she is 5 feet tall, and her shadow is 3 feet long. So how tall is the tree? We have to find this one. So what we do is we set up a proportion, just like what we did before. So x over 7.5 equals 5 over 3. It will be 3x over
Equals 37.5.
37.5, and then divided by 3 on both sides.
X equals 12.5.
Yep, x equals 12.5, which is the height of the tree over here.
Yep.
If a 36-inch pole casts a 21-inch shadow, how tall is the board that casts a 168-inch shadow? So again, we have to draw our own triangles this time. So the pole, yeah. And the 4 is 168. It's a lot bigger. and you have to find the x here. So what you do is you set up the proportion again. So x equals 168 equals 36, 36 over 21. So it's 21x over it's 0.6048 and you divide by 21 and you get 288 inches.
I was gonna write that.
Okay, so yeah, so that is the height of the fort.
So this x right here equals to 288.
Sam wants to enlarge a triangle with sides 3, 3, and 6 inches. If the longest side is 51, how long are the two other sides? Yeah, so this is an isosceles triangle because two of the sides are equal, and you have a long side which is 6. And over here it said that the longest side of the new triangle is 51. And so you have to find the proportion. So what you do is 51 over 6 for 51 over 6 and you get 8.5 and then you will times 3 by 8.5 which you get
25.5.
25.5 for the two new sides.
Wait, were we supposed to? I'm confused. Anyways.
A telephone booth that is 8 feet tall casts a shadow that is 6 feet long. Find the height of a mailbox that casts a 4 feet shadow. Yeah, so here you just do the same as all the problems before, set up a proportion and solve for the height. So it's x over 4 equals 8 over 6. So you get 6x equals 32 and divide by 2 on both sides. And you get x equals 16 over 3.
Yeah, 16 over 3 is about 5.3, but it's ongoing decimal.
On the height h.
Oh. Yeah, we're trying to find this. They already gave us diagram and the numbers are labeled here. So we just have to set up a proportion to solve for h.
And we know that these two triangles that are equal because there's a vertical angle here. That means these two angles are equal.
Are similar. The triangles are similar to each other with the right triangle as well. So h over 24 equals 5 over 8. 8h equals 120. So h equals 15 feet. this h here equals 115. Oh no, 15. And we're going on to similar or not similar. Basically, we have to figure out if this graph is similar. No, these two triangles are similar or not. And we see that we're missing out on some sides. We don't know the length of the sides, which then we have to find by using Pythagorean theorem. So basically, I'm pretty sure this angle here is a 6, 8, 10 triangle. And we can, since we know the size of the triangle, we can find the scale factor and then try it on to see if they are equal to each other. So 8 over 6 is 4 over 3, and 15 over 8 is not equal to 4 over 3 because 3 times this equals to 24. 45 over, and this one equals to 24, 32 over 24. So these two are not equal to each other. So these two triangles are not similar to each other because the sides do not have a equal scale factor.
So now let's take a look at these two triangles and see if they are similar or not similar to each other. So over here, we know that this triangle is an isosceles triangle because these two are both x. So let's see. So let's see like the scale factors. 90 over 15 equals
6.
6. And wait, we don't know if these two like triangles are similar because like we don't know the two sides and then they don't have the
angles either. Yeah. Let's skip this question. Yeah, not enough information.
So let's see if these triangles are similar or not. So like over here, you could tell that the size of this is 3. This is also 3. And the pink one over here, it's 6. The height of this triangle is 2. The height of this triangle is 2 also. So we know that these two triangles, they are like similar because there is the side angle side. The sides are the same, the angles are the same, and the other side is the same. So these two triangles, we know that they are similar. Now let's take a look if the big triangle is similar to these two. And the height of this is 1, 2, 3, 4, 4. Now let's see if these two, the big one and the small one, are in proportion. So 4 over 2 equals 2, right? And then 6 over 3 is also equals to 2. They have the same scale factor, which means they also have to be similar. So the triangles here, yeah, they are similar to each other. Emily, can you click? Okay, you click on the picture because I cannot see the numbers. Okay,
Is that better?
Yeah. Okay, so this triangle has like a unit of 1. This has a unit of 2, and this has a height of 2, and this has a height of 4. Now let's see if they have the similar scale factor. So 4 over 2 is 2, and 2 over 1 equals 2. So they have the same scale factor, which means they also have to be similar. So yeah, they are similar. Okay, make this bigger. So now we have to see if like there's like a lot of triangle here. This is one triangle. This is another one. And this is another one. And this is another one. So there are 4 triangles here. And let's see if like all of them are similar. So first let's do the 2 big ones. The 2 big ones, they have the same side, which means these 2, they are similar with each other. And they also have the right triangle, which means they are also right triangles. And now let's look at the 2 little ones. So, yeah. So 2, let's use a scale factor way to find out if these 2 are similar. So 6 over 3 equals 2, and 4 over 2 equals 2. So they have the same scale factor and the same angle. This is also a right angle over here. That means they are also similar because their sides are in proportion. And let's see if the little tiny triangle over here is proportional, similar with the rest of them. So it's 6 over 1 equals to 6, and 4 over 2/3. Now you have to
Which is
oh wait, this I forgot this is 2, so it's equal to 6. So yeah, they have the same.
they are similar.
Yeah, they are all similar. We just proved that they are all similar.
Similar. Okay. Oh my god, what just happened? Can you use similar triangles to find the slope of a line by looking between any 2 points on the line? Wait, how can you use similar triangles to find the slope of a line? Is it like that what they meant?
Yeah, they meant like they have to be on a coordinate grid and there's two triangles like the question we did before. Like they are all on a coordinate grid.
Grid, yeah.
So like if the triangles are similar, then they will have the same slope.
Yeah.
So you just have to find one of the side of the triangle. Let's say if they give you a point here, which is 1, 2, and this is like a negative. Wait, this is
No, that's positive, I think.
yeah +2, like oh I wrote negative again.
Okay.
+2, -3. So you just find the slope of this, and this should be like equal to the slope of this, because they're like similar.
Triangle. Triangles are similar. What does this tell you about the slope of the line? So for every single line it corresponds to, they all have the same slope. What conclusion can you make about this location, the hypotenuse, and how this relates to finding the slope of a line? Location of the hypotenuse. Oh, I think it's basically if you know the 2 points, you can know the slope and you can know the hypotenuse because the 2 points are where the hypotenuse is. Explain what makes these triangles similar.
So like we know that similar triangles, they have the same angle. As you can see, all 3 angles of these 2 triangles, they are the same angle. And the sides for similar triangles, they have to be in proportion. And as you can see over here, the 2 sides of the triangles are indeed in proportion. So that's why these 2 triangles are similar.
And also they have labeled the angles, which means that they are like the corresponding angles are congruent. Last question.
Explain why we can or can't find the missing part.
I'm pretty sure we can find the length, but we can't find the angles.
Yeah, because like there's only one angle and you don't know what the other 2 can be.
Yeah, but for the you don't know these 2, and then but for the length they provided 3. No, they provided 4 length, which is enough for us to find the rest 2. So here 10 and 15 are corresponding, and 21 and 14 are corresponding. So that means that we either have to find X or A by, actually, I don't think we can find it.
Yeah, because we don't know if like these two triangles are
Triangles-
similar.
Yeah, there's not enough information for us to find it.
So not enough information.
And that was, oh.
And that's it.
Yep. We got 9,000 scores, which is a lot. Okay, and I think that was all for today's lesson.